take it away.
Totally. Okay, I'll go first. Hi, everyone. My name is Priya. I'm a software engineer at ChainGuard. I work with Nathan. And I have been working on a bunch of different open source projects for the past few years, including Tekton, Sigstore, Minikube, if anyone uses Kubernetes. And yeah, that's me.
Hi, so I'm Parth. So I'm working at IBM Boxbook currently, so as a solutions architect. So I've been involved with like in Toto and getting involved with Tekton and pipelines and chains. So I'm very interested in the space. So I wanted to help out, especially with the SPIRE integration. So that's what we'll be showing today. Thank you.
Awesome. Okay, cool. Let's get into it. Okay, for some reason, okay, there we go. So yeah, quick list of things we're going to be talking about today. I'm going to do a quick overview of Tekton and Tektonchains, talk about the salsa framework a little bit, and then discuss why we want to integrate Tekton and SPIRE together. These are all like pretty large topics that I'm going to have to kind of cover in just a minute. So if anyone's like confused or has questions after this, definitely reach out to me. I can provide you with a lot more resources. And then Parth is going to do a demo of a prototype that he's been working on. And hopefully that should clarify any questions that you might have. So let's just jump right in. So what is Tekton? So Tekton is basically a CI/CD platform that was designed to work well on Kubernetes. It's completely open source, so you can find all the code on GitHub. And it basically provides a platform for users to build, test, and deploy on Kubernetes. And so kind of a Tekton pipeline can be run on any cloud provider that also offers Kubernetes. So think of anything you'd kind of want to do with your CI/CD, building artifacts, storing them in some sort of backend, running tests. You can do all of that with Tekton. So the basic unit of Tekton that we'll need to know for today's talk is called the Tekton Task. So it's the smallest level of configuration in Tekton, and it basically just lists out a variety of steps that you might want to do in your pipeline. You can deploy the task to your cluster where it can be used as a building block in larger pipelines. So on the right side, we have a really simple Tekton task, which just pulls in an Ubuntu image and runs hello world. If this looks kind of similar to a Kubernetes pod configuration to you, that's because the Tekton controller is responsible for turning this task into an actual pod that will run. So they actually have a really similar looking config for that reason. And then the other piece that you'll need to know is a task run. So a Tekton task run is basically an instantiation of the task. So on the right side, we have that same hello world task. When you apply that to your cluster, it lives in your cluster, but nothing really happens. To actually run it, you'll need to start a task run, which is on the bottom left. So the task run will basically just create a task run with some name hello-run, and it references the hello world task, which will kind of inform the controller which task needs to run in the cluster. And then Tektonchains is another Tekton project. So the idea behind Tektonchains is that it is basically supply chain security for Tekton. So you have the core Tekton project, which will kind of run a pipeline in your cluster. Anything that happens once that build is finished that you would normally do for supply chain in regards to supply chain security, all of that stuff is what Tektonchains is responsible for. So say you have a Tekton task run that is building an OCI image from a Docker file and then pushing it somewhere. You could use Tektonchains to sign that image in OCI, generate build provenance from the task run itself, sign that provenance, and also store it in any backend that you might be using. Tektonchains also leverages Sigstore under the hood. So we have support for keyless signing with full CO, which is the Sigstore certificate authority. And we also have support for storing public keys, signatures, and certificates in Recore, which is the Sigstore transparency log for easy discovery as well. So I know that was a lot of information. Here's a little diagram I made to try and kind of hopefully explain it a little bit better. So you have your Kubernetes cluster, and in that cluster, you have Tekton pipelines, which is the core Tekton project, and Tektonchains running. So on the left-hand side, you create a task run, say that it's responsible for building an OCI image. Tekton Pipelines is responsible for taking that task run, converting it into a pod, and executing it in your cluster. Once that task run is complete, it will have stored your artifact or your OCI image in some sort of storage backend. So on the right side, we have that storage backend, which in this example would be an OCI registry. Once the task run is complete, Tektonchains, which has kind of been observing the builds the entire time, will take the signing key that you have configured, generate some signatures, generate some provenance, and then store those things alongside the artifact in your storage backend as well. So what's the point of this? So we have this end user on the right side. When they download this artifact or this OCI image or whatever they need it for, they can use cosine, which is another Sigstore tool, to verify the artifact and verify the build provenance against the associated public key. So they can be confident about that the artifact was signed by a trusted entity, and they can also get information for all the steps that went into actually building the artifact itself. So, so the reason that we are looking at integrating Tekton and SPIRE is partly because of the SALSA framework. So SALSA stands for supply chain levels for software artifacts, and it's basically a security framework that is a checklist for software integrity. So the levels range from level 1 to level 4, where level 1 is kind of the most basic form of supply chain security, and then level 4 is super secure. And we want to get Tekton and Tektonchains to a point where users could achieve SALSA level 4 if they needed to, and have the most secure environment possible. At the moment, Tekton and Tektonchains can achieve SALSA level 2. So this comes with a couple guarantees. So the main ones are that builds will run in a build service. So that is Tekton. Provenance is authenticated and service generated. So that's the bit that Tektonchains takes care of. It'll generate the provenance and sign it for you. So obviously our next goal is to get to the next SALSA level, SALSA 3. And for this, we need Tekton to generate non-falsifiable provenance. So this basically means that we need the task run in the cluster. We need to be able to prove that it wasn't modified during or after execution. So this is where SPIFFE and SPIRE come in. And this is why we've been looking at this integration with Tekton. So for the Tekton and SPIRE integration, we plan on integrating the two to meet this non-falsifiable provenance guideline. And we want to be able to cryptographically prove that nobody has tampered with the builds during or after execution, so that people can kind of have this confidence that the provenance is not faked or manipulated in any kind of way. I'm giving a really high level kind of explanation of this right now, but if you're interested in the more nitty gritty details, I've linked our design doc at the bottom of this slide. So key components of how this is going to work. A lot of this hasn't been fully fleshed out, but this is kind of just our idea around it right now. Apologies if I get any of the vocabulary wrong, but the idea behind it is that SPIRE will be configured in the cluster to only issue SVIDs to the Tekton controller via a Kubernetes workload attester. So the idea is that the Tekton controller will take a task run, generate pods, and only it will be able to request SVIDs for those workloads. It'll take the private key that's associated with the SVID and sign the entire task run definition and store that signature with the task run. When the task run is finished, Tektonchains will verify the signatures with the X509 cert that's attached to the SVID. And if the signatures verify correctly, then we know that the task run hasn't been modified since execution. And in this way, we plan on cryptographically proving that the task run wasn't modified. And that way we can promise non-falsifiable provenance. So this diagram is the same diagram as before, but a lot more complicated. I added in a bunch of stuff in red so that it's a little clear what the changes are. But basically, we have just added in SPIRE into our Kubernetes cluster at the bottom. As the task run is executing, we'll have the Tekton Pipelines controller request the SVID and generate a signature over the task run. Once the task run is complete, it now also has the SVID and associated signature attached to it. So when Tektonchains tries to go in there, generate provenance and sign things, first it'll verify signatures against the X509 cert in the SVID. If the signatures If something goes wrong and verification fails, then it'll just stop there and we won't generate any signatures and we won't generate any provenance. But if it checks out, then we generate the signatures, store them in OCI, and we're good. And the end user will have the exact same experience, but they'll have this additional level of confidence in the attestation that they can see. So that was a lot of information. I'm gonna let Parth give his demo now, and let me stop screen sharing as well.
Okay, bear with me. I'm going to share a part of my screen. Can everybody see that? Okay, should be two pieces. Okay, perfect. So starting off, let me just talk about like what I have running. I have everything running locally on my cluster. So everything's built locally. So nothing is, like I said, like Priya was saying, it's it's all experimental, still work in progress. So all the controllers that are running, the pipeline controller as well as the chain controller, all using this work in progress code that Brandon, Lum, and I have been working on together. I'm trying to incorporate Tekton or SPIRE into Tekton. So you can see the controller piece. This is the pipeline controller. Here's a change controller running, and of course the SPIRE agent, the SPIRE server and the SPIRE agent both running here. What I did want to show is that we are incorporating the CSI, container storage interface. So we're using the container storage interface in place of the I think it was the host path that's usually used in order to mount the workload API, the SPIRE API kind of thing, right? So what this does is that it kind of takes out that that unwanted piece of having using host path to request between all the different workloads. So the only piece that really has the host path needed now is just the SPIRE agent. All the other workers would use this CSI driver in order to connect the SPIRE server or SPIRE agent and all that kind of stuff, and in order to request the SFITs and stuff like that. Just quickly showing the registrations that I did. So everything's already running. So SPIRE server, right? So registration is basically simple. All I did was it's just using the K8s_PS PSAT basically in order to register to the actual node, which is our SPIRE agent. And then the other piece is the actual Tekton controller pipeline. So the Tekton pipeline controller actually utilizes the K8s workload registrar. So it's built into it. And what that does is that it has the ability to automatically register different pods or different task runs in this case, right, into the actual SPIRE server. And I'll show you that running over here. Basically, once actually everything kicks off, you can see entries automatically being created in here that will show you that a specific task run will automatically get registered in here so that it can pull the SVIT out, right, and then do the signing and all that kind of stuff. So that's what this admin piece is needed down here to -admin, so that it has admin privileges in order for it to actually interact with the SPIRE server and create and store entries. And then once the task run is complete, the controller will automatically remove that entry. So currently there is nothing in here. You see the original Tekton controller, the Tektonchains, and then this is just the node that automatically gets created when the workload registrar actually does the registration of the node. That's the entry that automatically gets created. So that's what's in there. Of course, the last piece is the controller itself, the change controller. And again, that's being used so that it can authenticate and pull down the trust bundle to verify that the pipeline controller, that SVIT and everything is valid based on the trust bundle that it's utilizing. So what I'm going to be doing is I'm going to be doing a quick, I basically have a Golang pipeline that I've created. Quickly go through that. It has multiple different types. That's going to do, so I actually have it loaded in here. It's going to do some, it's going to clone the repository down. It's going to build it. It's going to do some, unit testing, stuff like that. It's going to build the actual image using Canico, and it's going to do an image scan basically at the end of it. So that's the pieces that we're going to run with. And again, if you guys need more details, you can always contact Priya or I later on, and we can walk through this in more details if you need, exactly what pipeline runs and how to construct all that kind of stuff. Yep, and let me see. I think that is everything. So I'm just going to run just running the pipeline. So it's going to automatically instantiate the pipeline here, and it's going to start making a pipeline run. So I reload this, it should automatically run it. So the first step it's going to do is going to do a clone, and once this once this first piece finishes, I'll talk about it in more detail. So the colon's done. Let me expand this out a little bit here. So in here, so this specific task run actually had results coming out of it, right? So it created a commit and a URL basically. So these are two things that the results that came out of this specific task run. So every time a task runs, it can have a result. So in this case, that run test did not have any results. So all you see in here are parameter status, and this is just the pod that the task run actually isn't running in the cluster. So this specific one actually had a result. So you see in here that if it has a result, then it automatically receives the SVID. And I did want to show you here quickly that it did add in. So you can see here's that build. So it's adding in entries as it's running. So here's a tribute scan. So that's the other piece here. So here's a tribute scan, and then here's that run build. So those are two pieces that are running. The clone already has ran, so it has automatically removed itself from the entry list. So as it keeps updating and as it keeps running, it'll add in all the different entries that it needs and remove entries. So you're no longer having to manually add in different entries for your pipeline. And it's still using the K8s workload attestation, the work plugin, so that it can attest to the different pod UIDs, what name it's running in and all that kind of stuff. So you can see it updated by itself. Now we're back to what we started with, the Docker desktop chains and all that kind of stuff. So it looks like the pipeline finished running. So I think Canico is still finishing up. Let's see. Yep. So Canico might show up still here. Yep, yeah, there it is. So Canico is the last piece that's running. So all the other task runs automatically deleted themselves, and there goes Canico. So Canico finished running also. Yep, so that's all good. So back to the results. So this specific task created two different results. It committed a commit and then a URL. So what we added in there was that we put in a results manifest. So what we wanted to know is that, hey, what pieces are being created by this specific task run, right? So commit a URL. So these two pieces need to be in the results. So that's what this is in there for, is that it kind of checks the pipeline controller at the end once the task run finishes, does a status check to see, okay, is the commit still there? Is the URL still there? It's something in the middle of while the pipeline was running, did something go in there and mess everything up, or maybe some bad actor got rid of the commit or changed the commit. We want to check to see that the result is still there. So that's what this is doing. Basically make sure that the results manifest has these two components. And of course, that's being signed by the SVID. So it requested the SVID from the SPIRE agent, which got it from the SPIRE server, and then attached it here so that it can utilize this in order to validate that the signature is valid, right? So what the controller does once the task run finishes is that it appends the SVID and also does all the signing, and then it also verifies everything. Once the task run completes, it goes back and checks to see that the actual output and the signature all match up and everything is valid. So at the end, you kind of see a status right here where it says that it's been verified. So it checked the signatures, it checked that the SVID is valid based on the trust bundle. So that's the other piece that it does. It checks to see that the SVID that it received is valid based on a trust bundle that SPIRE server is using. It also checks the URI. So it expands out the actual cert and checks to see if the specific URI matches. So in that case, it's looking at, I think in this case, the trust domain is example.com, right? The default one. So it kind of checks to see that matches, as well as it checks to see, the specific namespace that the task run actually ran, that matches, as well as the specific name for this task run also matches. So that's all part of the URI. So it checks all those three different pieces, so that we're not using another cert didn't get added in there by accident or something. It double checks that. And then finally, the manifest check, which I mentioned before, that the commit and URL are both there in the results and that they're both valid. Again, like this piece, this specific task didn't create any output. You can see there is no different output at all. So there is nothing associated with that. The last one, that the Canico, of course, that's the one that's going to be creating our actual image. So you can see that there is a image URL here. So this is the piece where it actually got created. The actual image got published out to that specific repository, as well as the image digest. You can see what the specific digest that's there. Again, same thing. It is a signature. There's a URL, and you can see the signatures here, and then the SVID attached to it. Again, the same similar checks here. So once this finishes, now the change takes over. So what, I'm sorry, one more piece. Let me go back over here. So if I describe the actual task run, this, and I'm just going to describe the Kaneko one. So once everything finishes, what the pipeline controller does is that it adds an annotation. So this is the controller SPIFFE now. So this is no longer the task run SPIFFE, but the actual controller. So the controller itself takes the status. So this status right here basically takes his whole thing, creates a hash of it, and then appends that to the annotation of the actual task run object that it's publishing out. And that's right here, and then also does the signature based on the SPIFFE. So it appends all this information, and this is where change would come into play. And change looks for this annotation and verifies that this SPIFFE is valid. Again, based on the trust bundle, it verifies that. It again verifies the signature and the hash are both valid. It also hashes up the status again. So you can see the status actually is an object. So right here, here's where the status starts for this specific task run object. So it takes the hash of this and compares that with the hash that exists in the annotation to compare, okay, when the pipeline actually finished, did anything change between the task run when it ended and when change checked it, right? So you want to have non-falsifiable all the way through the pipeline. So that's what that's checking. So that the hash, both the hash match. So now you're confident that, okay, nothing has changed. And then once all those pass, all those checks pass, that's when change will do the actual signing and will sign it with the specific. In this case, I'm using a cosine, like Priya was saying, you can use cosine. I just have a public-private key pair that I'm utilizing that change knows about and does the signing based on that. Yeah. So it signs this and it also creates the specific payload. So if I want to look at it, I can do, get the, there we go. Oops, not one. Kaneko, and then I'll just output this in YAML. You can see it creates a massive, it's in base64 encoded payload here. And I can just take this down and bear with me while I decode it here real quick. Should have done this beforehand, but apologies. It's very long. There we go. So base64, code that, and I'll pipe that to JQ just to show. So this is the provenance that gets stored, and again, this can be stored into multiple different backends. So in this case, I'm just appending it as an annotation, but it can be stored into OCI and Google, whatever else you kind of want it to be stored in. You can see exactly, so this specific one is the actual status, it looks like. So you can see what steps that took place. And you can see, the task run results and all that kind of stuff in here. And there should be another one that does the actual provenance. And again, this is a work in progress. Looks like that piece is missing, so I need to go back and look through that. But that's basically everything that's changed, as well as the pipeline controller is doing. Any questions? Anything I can go back over?
Any questions? I think Evan had a question. He said, how does this integration get deployed? Is SPIRE deployed under the hood, so to speak,
Right.
with Tekton, or does the user bring their own SPIRE or something else?
So currently SPIRE has to be installed manually. So I think this might be a piece maybe we work on, but currently we're thinking that SPIRE, that the user or whoever's using would incorporate SPIRE, basically would have SPIRE running on their cluster already. So currently SPIRE does not get installed with Tekton. Tekton will do its own installation, but SPIRE would have to be installed separately. The piece that it does do, and there's we added some feature flags and stuff like that, is basically the deployment. So it automatically takes in, it has the SPIRE. So let me move this out of the way. So it does have, the SPIRE CSI driver in there. So that will be handled by Tekton. So we're still working out the details on this, but basically there, maybe some kind of a template or something, maybe using Helm two different versions that either have SPIRE or non-SPIRE versions, so that it'll automatically come with this the CSI driver and all that kind of stuff installed, so that you don't have to worry about that. So once the SPIRE server is running, you can have it attached to the controller, pipeline controller, and the chains controller. The registrations would still need to be done manually, as you normally would, manually adding in the chains. But maybe this can be a documentation piece that we add in. You know, if you're using Tekton with SPIRE, we already started like an article of documentation how to set it up, and you know what needs to be added in registrations and stuff like that. Anything else?
Any other questions? You can put in the chat window, or if you want to unmute yourself and ask the question.
Hi, it's Antu. I'm sorry I joined very late, conflicting calls. But will this recording be available shortly? Somewhere?
Yes, we'll make it available by early next week.
Thank you.
All right, thanks everybody.